Hello, hi guys, good morning, welcome back to a new video. In this we're going to see problem number 4 of today's bi-weekly contest. A big disclaimer before starting to even solve this problem. The time complexity which I'm going to show you will actually be O of n raised to power 5. Now if you see n is 50, so n raised to power 5 will come down to nearly about 3 into 1e8. Right now, usually 1e8 is a tight pad complexity for any platform, usually specifically for Leetcode. Again, code forces 1e8 can still work, but Leetcode we have seen that 1e8 is a very tight complexity and usually it fails, it gives TLE. But this problem actually passes n raised to power 5 time complexity, although it should ideally not have passed, and this is actually the best solution on the entire Leetcode so far. Every solution right now you can see here will actually also discuss the same approach. So just a quick thing that maybe in future what might happen is that maybe the constraints get a bit low, or maybe Leetcode they improve the test cases, but I don't think so, because no one did a code submission whose time complexity was actually less than n raised to power 5. No one did that. Okay, so now let's see what the problem is saying. Again, that was a big bit of a disclaimer in the beginning, so as you to know that okay, what you are about to watch. Please don't say I scammed you. Cool. The problem simply says that you are given an integer array nums of length n. Okay, which means I have an array. Whenever I say okay, I remember that meme. Okay. So I have an array nums and that size is n, and we have a positive integer k. Okay, we have nums and then we will have our k. Okay, we have k and we have nums. Now we have defined something as called as power. We will see that later on. What is the power? Now the thing which we have to return is the sum of power of all subsequence of nums. Break it down individually. Imagine that you have nums. Again, exact same nums which we have it here. Let's make it here also. Imagine you have nums. You have to grab the subsequence of that nums. Now, if I ask you what is subsequence of a number, simply take any element in the order. Let's say I take this, and I take this. So these three elements will actually make a subsequence for me. Okay. Now I also know that in a array of size n, I can have 2 raised to power n number of subsequences. Cool, because for every element I can take or not take, because in this array itself you can see for this I did a take, for this I did not take it, for this I took it, for this I did not took it, for this I did not took it, for this I took it. So for sure I will have in total 2 raised to power n possible options to take or not take. Now again, this will boil down to future things also, so make sure that I taught you this. Now coming on back, we will have this as one subsequence, but again going on back, we have to find the power of this subsequence. Again, remember, this is the subsequence so far which we have got. Now we have to find the power of this specific subsequence. Now come back to what is the definition of power. Power of a subsequence is defined as minimum absolute difference between any two consecutive elements in the subsequence. Now if I replace, again as you can see I have made a subsequence, so let's replace the subsequence and imagine that I have an array of size 3. It will be a same fact, right? Now let's replace all these words here which say subsequence as array. Let's say array A. Of difference of any two elements between the array A. So now the problem boils down to that in this array A, we have to find the minimum absolute difference between any two elements in a subsequence. Now again, break it down again. What is any two elements in a subsequence? What is the absolute difference between any two elements in a subsequence? For sure, I can take, let's say I have A, B, C. So I can for sure take B minus A as one difference. I can take C minus B as one difference. I can take C minus A as one difference. And for sure vice versa also. Let's say A minus C. But again, I want to take absolute. So C minus A and A minus C both will give same result. So technically you saw that how I can find the difference, or basically the absolute difference. But the condition is I want that difference to be minimum. You see how we are breaking the problem and then making up the big problem? That's how you should actually solve hard problems. So basically I want this difference to be as minimum as possible. Now if I give you a few numbers, let's say 4, I give you 2 and I give you 6. And if I ask you, bro, you have to find out the minimum difference between any two numbers in the array. Now you know that if the subsequence, again, remember this is a subsequence. If the subsequence length is n, the possible pairs I can have are n square. And then I will have to go and find the minimum out of all these n square pairs. Can we optimize it? That's the first question for you. Can we optimize it? Yeah, for sure. Because if you remembered, if I just ask you what all pairs will be there, okay, the pair will be 2 minus 4. Again, remember the fact that I will take the absolute. So let's put it as 4 minus 2, right? Okay, 4 minus 2. I can have 6 minus 4. Okay, I can have 6 minus 2. I can have 6 minus 2. Now, these are all the possible, again, right now, this is possible values of pairs difference which I will have. In this, out of all these, I have to take the minimum one. So a quick question from my side. How and what makes two number difference to be minimum? Again, consider the fact right now is that this number is high and this number is low. Now I want this, again, this is a difference. I want this difference to be as low as possible. This difference will be as low as possible only and only when these two numbers are as close to each other as possible. So what I can do is instead I can simply sort this entire array. Again, this entire array is a subsequence. I can sort the subsequence out. I will get a 2, 4 and 6. Now I know that the difference between two consecutive elements will be as minimum as possible. So I can take the difference from between 4 and 2. I can take the difference between 6 and 4. I would not need to take the difference between 6 and 2, which I was taking when I was considering all the possible pairs. So that's one thing which we realized, that we can simply sort, again, we can sort the subsequence. We have not talked about sorting the array. We will see that part also, but right now we have reached a point that, okay, we will sort the subsequence, and by sorting the subsequence itself, we might end up actually getting up minimum difference. Okay, so that is how I can get a power. Again, the power is whosoever is giving. Again, let's say, imagine it would have been 8. So your difference would have been 2, which is the minimum difference. That is the minimum difference. This minimum difference is your power. That is actually your power. So this power you can get for a subsequence. Okay, and then sum this power for all the subsequence which you have and get the result. Again, this sum can be very large, so do a modulo. Now you have got the basic understanding of the problem itself. But Aryan, one thing, as you said that an array can have exponential number of subsequences, and for every subsequence you are saying that you will generate the subsequence, then you will sort the subsequence, then after sorting you will actually go linearly to find the power, which is the minimum difference. Are you seeing that part? I'll say, can we break it down? Again, we will find the nums, we will take the subsequence. Again, if you remember, subsequence is nothing but saying elements are being taken in this order. But as soon as I take the elements in the order, I am sorting it, which means for me order is not even important in the first place. So why I would take the subsequence and then sort it? I can directly right now in the very beginning itself sort it, so that after sorting whatsoever subsequence I am taking, again, so sorting, after sorting whatsoever, again, this is sorted, so it will be 2, 4, 8, 10 and 14. So this is now sorted. So after sorting, whatsoever subsequence I will be getting will always be sorted. So for every subsequence I will not have to sort. Okay, this is another thing which you optimize. So far we have optimized two main things. One main thing is how we'll find the difference. From n square we reduce that to n, and then for every subsequence I would had to sort again and again. So that would have added a n log n multiplied by n log n thing. It would have added that again and again, but now I can just do a pre-computation, as in I can just simply sort in the very beginning itself. That is another improvisation which we did. Now still the main crux was, Aryan, you still have to go and find the subsequence. In that subsequence you will still have to go and find this power and then add this power. I think it will be still subsequence finding is a very big operation. I'll say, yeah, bro, you are true. But in these subsequence cases, okay, when you have And how you build the subsequence? By simply saying take not take. Okay, you know that things are going exponential. You know it's a take not take operation in the very beginning itself. So why can't we think of just applying a DP? Again, we never know that maybe DP actually also needs some bit improvisations, but let's think of applying DP at this place. But before that, let's see one thing also, that our length of the subsequence should also be equal to k. So again, if I go back to a simple example of a subsequence, again, imagining that you have this subsequence, you have this array nums, you have to generate the subsequence. So usually, for sure, in a subsequence, you will need one thing, which is index. Okay, so how usually things goes is, okay, you will have an index. That's the only thing which you need so far. And then in the, again, let me erase this entire thing. Now in this actual solve function, again, remember the solve function is nothing but a recursive function which you will memorize. In this, if I'm saying I will apply memorization, so I will just say I'll do a take not take. I'll do a take not take. So let's say if I do a take, again, I'm just showing you a pseudocode. If I do a take, so I'll just say simply solve by taking, okay, by taking the current Aryan, but okay, if you take the current, what will you change? I'll ask you. What will you change? See, if you take some element, what will happen? If you take some element, what will happen? You need to find what? Again, you can take Aryan. What I will do is I will make a vector. What all elements I am taking, I will put that in a vector. Let's say if I took at 4, I'll put that in my vector. I did not took a 4, sorry, I took a 2, I'll put that in a vector. I did not take a 4, will not put it. If I take a 8, I'll put it. If I take a 10, I'll put it. If I did not take a 14, I will not put it. So this will be a vector. And ultimately in the super end, I will just have a quick check. What is the minimum difference? I will iterate on this vector itself. I'll say, you are going right. You are absolutely going right. But do you see that you are saying that, okay, at this iteration, which means solve of I plus 1, you are saying that, okay, you will parallel, again, this is for take, you will make a vector. In that vector, again, that vector, you will make a vector. In that vector, you will pass in nums of I. So let's say vector, let's name it as current vector. So you will do a pushback of nums of I. And then that current vector, you will be passing in this solve function. So that, okay, later on in the future also, I can just solve it. This is one thing which we are thinking of. But as soon as you know that Aryan, when will you stop? I'll ask you, when will you stop? Simply, you know that you want your length to be equal to k. So I can just simply say, bro, if my current vector dot size, if it becomes equal dot size, okay, why is my handwriting so bad? If my current vector dot size, if it becomes equal to k, which means I'm good to go, I should stop. Now, when I say I should stop, I should iterate on this entire current vector and find the minimum difference. Find the minimum difference. Minimum difference. Now, things seem fine because you are iterating, then you will be having this current vector also, and then you can just keep track of this k will be constant. But bro, do you see a very big blunder which we are having? The very big blunder which we are having is for I, we are storing the entire vector of size n, and that I, every state this vector will be changed. So we need to move away from this vector right now. How? What this vector was doing? This vector was helping you to find minimum difference. To find the minimum difference, what you were doing is, okay, if you were at the index I, you were subtracting, okay, let's see, if you have this current vector, so you are doing current vector of I minus current vector of I minus 1, right? And then this is a diff, and then you will go on and iterate on the entire array and get the minimum diff. This is what you are doing with this current vector. Now I'm saying let's replace every function of this with a variable. What I mean by that is that, okay, this I, already I have the I. Aryan, this I and this I both are different. Okay, you got it. That is absolutely correct. Both the I's are actually different. This is I, let's say name it as J. This is the J vector for the current vector array. J, let's name it as J. Now this is the difference. Now, if I ask you, bro, you have to return the minimum difference. So that is what you have to return. What you have to find out is this difference. And for all these differences, you have to return the minimum difference. So I will say one thing. Why can't you simply keep on generating the minimum difference itself? Which means while you were actually, see again, this is your nums array. You were having these elements. Now again, you have options, take, not take. When you were taking, you were actually putting that in your current vector and saying, okay, I took this element. Okay, let's make of the same size. So you were taking and saying that I will put this in your vector, current vector. Okay, you were taking that. Now when you were not taking it, you were saying, okay, still when you will take, okay, not take, when you will take this one, then you are putting here itself in the current vector. That is what you were doing. Now I'm saying the exact same stuff. So you were at I. So this is your exact same I. But this I minus 1 is not your this I minus 1. This is something else. So I can keep a track of this specific last index. You see, this last index will be representing my I minus 1 for my current vector. So I'll say let limit as Li, last index, or let's say Li. So you saw that from this nums array, I actually was able to regenerate my current vector array. But Aryan, you just only were able to find out 2, which means I and Li. But you, Aryan, you want all of them. Absolutely fine. What I will do is, as soon as I know I have to shift, okay, let's say I will not take this, but I will take this. So for sure my I will shift, but before shifting my I will bring my Li here. And the same way I will be able to actually replicate this entire current vector by simply I and last index. But Aryan, still you forgot. Ultimately in the super end, you have to find the difference. You have to find the difference. So are you saying that you will maintain these indexes rather than the array? No, it will still be same thing. Why I will maintain the indexes? I will not maintain the indexes. I simply wanted one thing. I wanted the difference, and I wanted that to be minimum. So when my I was here, I will find the difference here itself, which will be nums of I minus nums of last index. Aryan, but you forgot the difference needs to be absolute, bro. This will always be positive, because if you remembered, we had already sorted our nums in the very beginning. So this is already sorted. So this will be diff is positive. Now this is the diff, current diff. As your I will move, okay, I moved here, for sure your Li, you will actually correspondingly move in the place of I. Now you remember your maksad nahi bhola. Your main aim was that you have to minimize your diff. Ultimately in the end, the minimum diff is actually the power. So right now, for again, let's imagine this as diff 1, which was a diff in the very beginning. For this I and Li, let's say I find out again the diff 2, which will be nums of I minus nums of Li. Now this again, let me add in the big good handwriting. So nums of Li. So this diff 2 is the current diff. But remember, maksad kya tha apna? Our aim was to find the ultimate minimum diff. So why can't I right now itself take the minimum diff with, okay, existingly I can say this was my minimum diff, which was the diff 1. So I will just minimize my minimum diff by the any upcoming diffs. So I will say minimum of minimum existing diff and the diff 2, which means the current diff which we have. Current diff I will be finding at every step of I, and minimum diff will be the diff which I will be actually having, and I will simply keep on propagating that minimum diff. Okay, simply propagate that minimum diff, because ultimately this is what I wanted. And as soon as I will reach the end, how I would know, Aryan, I have reached the end? When as you remembered, you will reach the end when your current vector size has become equal to k. But Aryan, right now I was not maintaining current vector. I was maintaining current vector's answer with the help of minimum diff, minimum diff and I and last index. This was helping me to find the answer for that current vector. So that is the reason with these three variables, I did not need to maintain or track the elements of the current vector. But Aryan, ultimately to end this, I should be knowing the size, or ultimately I should directly say I should be knowing that have be taken k elements. We should exactly take k elements. So what I can say is, okay, my ultimate aim is to take k elements. So in the very beginning, I will say that my remaining k is k, and I will keep on consuming. Okay, as soon as I consumed one element, I will reduce my remaining k by 1. Okay, I consumed another element, reduce your remaining k, consume another element, reduce your remaining k. So with this fashion, your remaining k is reduced as soon as your remaining k becomes a 0, which means I have consumed all k elements. I have consumed k elements. So I can simply say strictly, okay, as I can replace this exact same condition which was in the base case condition, I can simply replace by saying if your remaining k has become equal to 0, simply return what? Return what? This minimum diff, because you have been finding this minimum diff so far. So I'll simply return this minimum diff. Now things look a bit sorted, because you know that you will have a remaining k as a variable, you will have a minimum diff as a variable, you will have a I as a variable, and you have a last index as a variable. Now if I go and look back again, simply like low key, it feels like, okay, minimum k will have a boundation of k, index I has a boundation of n, last index has a boundation of n. This minimum difference, Aryan, this minimum difference is actually difference of values. Now if I go back and check the values are actually 188. So Aryan, are you saying that this will be 1? Where is it gone? Okay, so Aryan, are you saying this will be 188? I'll say no, bro, this is minimum diff. So if you were about to make an array, then it would have caused you an issue. So 188, again, the value of minimum diff can be actually 2 into 188, which is very high. So that's the reason I will have to memorize. I know that part, but I cannot use a vector, because vector cannot afford to have a 188 as your space or time. So I cannot afford to choose a vector. But Aryan, even if you choose a vector or something else, but still the time will also be 188 contribution of this minimum diff, right? Nah. So I will do one thing, okay, rather than choosing a vector, I know I cannot choose a vector. The only replacement of this vector is simply our map. Now to be on safe side, to actually stay away from time complexity issues, as in to stay away from TLE, I will use an unordered map for sure. If you use a map, you will get a TLE, right? Because it's very on the edge of a time complexity. We will see what's the time complexity, but still it might go at the edge of the time complexity. So we will try to use unordered map only. So far we know, okay, k works good, n works good, n works good, but Aryan, what about this minimum diff? Simply, minimum diff is nothing but the diff. I will ask you, bro, now you should not be concerned about the value of minimum diff. You should be rather concerned about how many such diffs can be possible, because I know I will use an unordered map. So value, which means diff value can be anything. I can still accommodate that, but time complexity will actually be dependent on how many number of diffs can be possible, because ultimately this is a minimum diff. So ultimately a task is how many number of minimum diffs can be possible, which directly infers how many diffs can be possible in an array of a size n. Let's say array of size n. How many diffs can be possible? Okay, one diff is this. Okay, another diff is this or this. Another diff is this or this or this. You see, n square number of diffs can be possible in an array. So this minimum number of diffs, these can have at max n square number of distinct values, right? So you will see your time complexity will boil down to n square, which is for diff, n for I, n for last index, and also your k. Now coming on back, your k was actually also bounded by n, so it will be again a n. If I go back, it will be again a n. So you saw it will be O of n cube as the time complexity, and also we will have to use memorization. So we will actually also have to use all these same spaces also. Now let's bring it down what we have studied. So we saw that we will have to use, again I'm just trying to write it down, exact same stuff. We know that we will have to use a I that will help us to move on to all the indexes. We will have to maintain the remaining k. How much k is remaining? Why is that needed? Because only if the remaining k is 0, then I should return whatsoever minimum diff I have actually found out. Again, remember to do modulo at every step. That is very important. But still, this is what we want. Now, again, another thing is, Aryan, what if remaining k is not 0? Because if you remember, in a simple base case of these kind of subsequence problems involving DP, you will have to know, okay, your I should not go much beyond, else you will get a runtime exceptions. Because what will happen? Here you will have a memoization step. Right here you will have a take not take case. Take not take case. Now in this take not take case, we will see what will happen, but this will be a take not take case. Now what were the other things which we actually required? So we will have remaining k, we will have the minimum diff value. Again, remember to make sure to put everything which can be big as LL, because the things can go pretty much large. So remember to take things which can go big as LL. So right now I just for showing, I'm taking everything as int, but in the code I'll show you everything as LL. Now, okay, I will have a minimum diff which I will be finding at every step. You remembered I need one more thing which will be okay. You remembered I have index, I have minimum diff, but I did not have last index. So I also need my last index. Okay, last index I need. Now let's come on back. Now, what will be the other base case? Simply, what if your I exceeds your actual nums array? So let's take your nums array also as a vector. Okay, because that's a constant thing, so I'm not writing it, but remember you have also a nums array. So I'm just simply saying if my I actually reaches my n is the end of nums array, so I can simply say it will be nums dot size. If that it has reached, simply return what? Simply return what? You will ask, return what? If you remembered, you have to return the sum of powers of all subsequence which has a length of k. If something is in, where is it gone? It is lost. Oh god. Yeah, here it is. So if something has not size of k, I will not add its contribution. When I say I will not add it, I will simply add the contribution of 0 to its sum. Right? Okay, great. Now comes the part where you will try to memorize stuff. You know that you have these states. So simply memorize that. Simply saying if your dp of I remaining k, your minimum diff, and your last index, if that is not equals to, basically it is actually not present, again because you cannot put not equal to -1, because if you remembered, you have to take a unordered map or a hash map you have to take, which will take again the syntax is that you can have only one key. So I will have to make an unordered map, like okay, unordered map of which is key, again an unordered map, again having one key, again an unordered map for it. So this will be a syntax for unordered map. I'll show that in the code, but unordered map is it will need to have only one key. I cannot put something like okay, unordered map, a list of ll, which means int. I cannot put like this, int and int, and then comma, and then int, and then map, comma map. My writing is so bad, but yeah, this is the list, which means unordered map where the key is a vector and the value is a simple int. That is not possible in an unordered map. You need to have single thing, either in the key it should be either a string or a double or a float or an int, like this. It cannot have a pair. In the key, I'm saying in the key it cannot have a pair, it cannot have a vector, it cannot have anything in an unordered map. So what you will have to do is just for the C++ folks, you will have to bring okay, key is just int. The value again can be an unordered map. Again with the key of int, again the value can be an unordered map. So as to make a chain of int 4 times. Cool. Now coming on back, we will just simply again that check also needs to be a bit modified because of how we make it this unordered map, but I will show that in a code. But this is a check which we will do. Coming on take not a condition. Again, if I take something, what will change? If I take something, the things which will change are Remaining k again will reduce by 1. I for sure, even if I take or not take, still I will actually increase. Minimum diff is the one which will actually be impacted, and the same way last index, because you remembered last, if you remembered, if I take something new, then the minimum diff needs to be reduced with the new diff, and new diff is current, like nums of I minus nums of last index. So it's this thing which actually impact my minimum diff, and again I will have to replace my I with the last index. So if I take something, what will happen? First thing will happen is that my minimum diff, okay, where is it gone? Yeah, it is same. So my minimum diff will actually become again minimum of minimum diff so far, comma your current diff is nums of I minus nums of last index. That is your current diff. Again, make sure to do a modulo at every step. Here also you need to do a modulo. Now when you have this minimum diff, you know one thing, that what if you would have taken, you will simply go to I plus 1 as the index, because for sure you will go to next index. Your remaining k will reduce by 1 because you have taken something. Now your minimum diff is now the new minimum diff. Let's name it as new minimum diff. So this is now your new minimum diff, and also your last index will actually be changed to your previous I, because you have moved to I plus 1. So your this I is actually the last index for the next upcoming ones. So this is if you will take. What if you will not take? For sure, if you not take, okay, still you have to move on. But if you not take, remaining k will remain remaining k. Minimum diff will still remain minimum diff, no change, and last index will also remain last index. But what will they return? They need to return what? The sum. They need to return this specific sum. So what? यार ये हमेशा खो जाता है. So this will return a int of sum 1, and this will return an int of sum 2. Now ultimately you have to add the contribution. It's a subsequence, so either take or not take. So sum 1 plus sum 2. Just simply again remember to do mod at every step. So do a mod. Again, mod will happen here also, and everywhere mod will happen, and then ultimately return that. Again, make sure to memorize this. Put a simple memorization condition that okay, dp of I remaining k minimum diff and also last index, this is equals to this value, which is sum 1 plus sum 2 mod k, and that is how you can simply solve it. Now let's see the code. Again, you saw the time complexity for this is actually O of n raised to power 5, and same way the space is also same, because you see that this is the dp which will actually internally can go on to n raised to power 5 different states. Now the code is pretty exactly same, just condition which I will show you to make sure that when you're writing, please make sure that how you should write. In the very beginning, I will say okay, starting from the index 0, remaining k, okay, in the very beginning remaining k is k itself, initial last index in the very beginning, because in the very beginning I have no last index, so by default -1. This is the minimum diff in the very beginning, and this is the nums which is constant. So these are the I, remaining k, minimum diff, and also my this is my last index, and this is my minimum diff. Cool. Now I'll simply call my solve function, but before that, remember, I have to sort my nums. Okay, now I called my function. Remember, I have to build my own dp, and that should be an unordered map. That cannot be a vector. If it is an unordered map, for sure you know that in a map my key needs to be only a simple value. So the value can be anything. So value here will be another unordered map, which will again have a key as a ll, then again an unordered map, because and a key again a ll, again an unordered map, again the key as ll. So you see, we have now 4 keys, so that we can access our I, remaining k, last index, and diff, and I can assign that a value. This value will be this value which I can assign. So this is for the 4 keys which I wanted, and this is the value. This is the reason how I can use an unordered map. Make sure you cannot put a vector or something like that in an unordered map here as a key. You cannot put it because the hash won't be able to compute. If you want to put it, you have to write your own custom hash which will have for sure hash collisions. Now coming on back, we will simply do one thing. If the remaining k is 0, return the diff. Again, as I told you, do a mod at every step. It is safe side. If it is I equal to nums of, if I is n, simply return a 0. Now, to have a quick check if you have already found this earlier or not, simply check again. You cannot directly write dp of this state. If your dp of, let's say, like remaining k is not present, which means if your dp of I is there but remaining k is not there, so this will give you a runtime error. So you cannot directly access something if something is not present. Okay, like as in you can access it, but you cannot check it. To check it, you have to check it individually. Okay, is I there? Okay, if I is there, then is remaining k there? If remaining k is also there, is last index there? Then if last index is there, is diff is there? If that is the case, then I can simply return my I remaining k, last index, and diff. Okay, now simply take not take. Sum 1, sum 2. Exact same stuff. I plus 1, remaining k minus 1, I, new diff, and nums. Okay, same I plus 1, remaining k, last index, and diff. But the change here is, okay, to find the new diff, Aryan, you have put a if condition. Yeah, for sure. Because if you will not put this condition of last index, you will end up accessing nums of -1. That is wrong in C++ and Java. Because you remember last index you have put in as -1. So when your last index is -1, your remaining diff, or basically your new diff, will still be same as the original diff, which is long max. If you have last index, then only you can easily go and find nums of I minus nums of last index and do a modulus at this step to find the diff, which is the new minimum diff. So this is a new minimum diff, and I will simply pass this new minimum diff. And ultimately, I know that I have to add these because I want the sum for all the possible subsequences, which means take not take, I want the sum for it. Assign this to our DP and simply return that, and ultimately getting the answer. And thus you see, I see that time will be O of n to the power 5 and space will also be O n to the power 5, and that's the answer. Cool. I know it's a big video, but yeah, that's a hard question. It is marked as 7, but yeah, I hope that you guys got it. It was not that hard considering, but still less submissions because people thought of that n to the power 5 will not pass, and ideally it should not, but still it passed. So yeah, cheers, bye bye, take care, goodbye. I hope that you got it. Bye bye.